Hi guys, so today we are going to start the first session of our blind 75 must do lead questions. The solution to these questions will be in Python, and I'm going to solve one problem daily from this. Just to give a brief overview about myself, I am Shashank and have been working in the software industry for the past 3+ years, and I have expertise in Python. So let's start by solving the first question, that is the two-sum question. So I'll share the link to this page in my description. Please check out the description. So let's start with the two-sum problem. So as you can see, this is a pretty basic and easy problem. Given an array of integers, nums, and an integer target, return indices of two numbers such that they add up to a target. You may assume that each input would have exactly one solution and you may not use the same elements twice. So basically what the question is saying, that let's suppose I have an array which looks something like this, which has 2, 7, 11 and 15 as elements, and I have got a target integer called 9. What I need to return is the indices of two distinct elements, or not even exactly distinct, but two elements having distinct indices such that they add up to form this number. In this example, as you can see, the element at the 0th and the element at the first position, that is 2 and 7, they add up to form 9. So hence we get the output of 0 and 1, right? In the second example, you can see the element has 3, 2, 4 and the target is as 6. So if we add 4 and 2, we get 6, and hence the output of 1, 2. In the third example, you can see like 3, 3 and the target is 6. If we add 3, 3, we get 6, and hence the output of 0, 1. So we'll start coding this problem. So we'll look at the brute force approach, then we'll optimize that approach, and then we'll further optimize that approach to reach to a most optimal solution for this problem. So guys, the first approach which we are going to look at is called the brute force approach. So I'll start coding the brute force approach and I'll walk you through the exact logic. So I'll call this class as brute force, and I'll define a method called solution in this class. Obviously the solution class takes an input of nums, which is actually a list of integers. This is our raw data, the input data basically, which is coming, the input list. The second element which it takes is target, which is an integer, and it returns a list of integers containing the indices of the two distinct elements which add up, two elements which add up to form target. So what I'm going to do, I'm going to write the solution steps here, right? So this is obviously the brute force solution. So what we do first, we create an outer loop which runs from 0 to length of nums minus 1. Then we create an inner loop which runs from I plus 1 to length of nums minus 1. And what we do is we add the element at ith position and the element at jth position and check if the sum of these elements is equal to the target element. If it's equal, we return the indices, otherwise the loop goes on. I write small descriptions about the input parameters, which is nums, which is a list of integers given as input. The target element which is the summation of the two elements in the list. What it returns? List of integers which list of indices which add up the elements at which add up to target. So quickly I'll write, this is a brute force solution, it's a very easy solution. I'll quickly write this solution for you guys. For I in range 0 comma length of nums, then for j in range I plus 1 comma length of nums, if nums of I plus nums of j is equal to target, we just return I comma j. So this is a simple brute force approach. We'll just write a small test case to test the solution out. So I recommend you guys to learn to write this testing this your code using the unit test module of Python. It will help you to enhance your unit testing skills also. So I'll just write this class called test brute force, which extends the class unit test.test case, and I'll just write a test underscore input 1. I will define the nums list here, and I will define the target here. So I'll copy the nums list from the top here, and I'll just paste it here. I'll copy the target here, and I'll just paste it here. I'll create a small object of this brute force class, and I'll assert equals. So as you can see here, the expected output is 0 comma 1. So I will just copy this and I will paste it here 0 comma 1, and I will call this obj dot solutions and pass the nums and the target. Actually it's giving me, okay, yeah, I missed the square brackets here and a comma here. So as you can see, like, this is my test case to test if the solution works. So we'll walk through the solution. It's a pretty basic solution. What we do is I 0 to let them, j is from I plus 1 comma, if this is equal to, if adding these two numbers gives you target, then you simply return I comma j. Let's run this test case and see if it works. So as you can see, the test results is pass. So basically this test case works, which means we got the input of 0 comma 1. Now this is the brute force approach. We'll try and paste this approach on Leet Code and see what is the best case scenario results which we get there. So I'll just copy this to Leet Code. I'll paste it here, and the indentation got messed up. So now I'll try to run it. Let's see. Okay, so it passed. So I'm going to run it like for all the test cases and see like whether it's working or it's not working. So as you can see, the solution passed, but the performance is very poor. So it is taking around 17.48 memory wise, and it is taking around 1681 milliseconds. So that's a very poor solution. It's beating only 29% of the Leet Code Python solutions. So next, what we are going to do is we are going to optimize this solution using some approach, some hash maps and hash sets. So yeah, let's go towards that. So guys, previously we have seen the brute force solution. Now I'm going to write an optimized solution using the implementation of hash map. In Python, the hash map is implemented as a dictionary. So let's solve this question and optimize the time taken for this problem to run. So I'm going to create a class called semi-optimized, and inside this class I'm going to again create a function which is called solution. So I will be basically copying this line from top, putting it here. Now I'll be writing the solution approach. So what we do, the first step what we do is we traverse the list and create a dictionary which contains the element of the list as key and their indices as values. The second step what we will do is we will traverse the list again and calculate the difference between the target element and the current element in the current traversal. Now what this difference gives us is the element which needs to be added to the current element to get the target element. Now the element which needs to be added to the current element to get the target element, if it is present in the dictionary, which actually means it is present in the array. So if it is present in the array, then we can say those two elements exist and we can return the index of the current element and the index which we will get from the dictionary. That will basically comprise of our answer. So the third thing I will write is if the difference exists in the dictionary, which means our pair of numbers is present and our solution pair is current index and the index we get from the dictionary. Okay, so again I'm going to copy these descriptions of the parameters from the top because they remain the same. Okay, let me just copy it for the sake of clean code. Okay, now what we do is we create a nums dict and we call it a dictionary. Now I do the first traversal for idx comma element in enumerate nums. If element not in nums dict, what I do is I just take nums dict element and I assign it to the index. The second thing what we do is, now this is our numsticks. Now our numsticks dictionary is ready. So we traverse the list again. I write here nums again and we calculate something which is called current required, which will actually be the difference between target minus element. If this current required is in nums dict dot keys, what we do is we return the idx comma nums dict dot get current required. So what effectively we are doing is we are iterating over the list and we are checking if the current required element is present in this dictionary. We return the index of the current element followed by the required index of the required element which is present in this dictionary. So we will try to write a test case for this implementation and see if it works. Now let me tell you, it is not going to work, it is going to fail, but we'll see why it is failing and we'll try to correct that. So for that, like first let me write the test case. So if I copy this semi-optimized from here and just paste it here, and I just, okay, so we see that for this test case, its parsing is running fine. We are getting test results as parse. So what we're going to do is we're going to copy this and try to run it on Leet Code and see if this passes. Okay, so we are going to run this on Leet Code. Let's see if it passes. Oops, it failed. As I told you, it is going to fail. So what is the issue here? So basically what is happening, in the output you can see we are getting 0, 0, which means 3, 3 adds up to give 6 as the target, which means that we have not taken care of the implementation that both the indices which are there are same. So it is actually returning as the result in the cases where both the indices of the element is same, which is basically counting the element twice. So we need to rectify this issue. So how we can rectify is we can simply add here and statement and say that idx is not equal to nums.get.required. Now what it does is, in case if idx is equal to nums.get current required, this complete method becomes false and it doesn't return. So we avoid that identical mistake here, like the same element being counted twice, so we avoid that here. So let's try and paste this solution again on Leet Code and see if it works. So I'll just go here and paste here, run it again, and boom, the solution passes. Let me try to submit it and see the result, how better it is performing compared to our previous solution. Okay, and as you can see, let me just run it again. So I'm just submitting it again. Let's see. So as you can see, 66. So it beats the 52.58% of the Python solutions. Previously, it was not even beating the 17% of the solutions. So yeah, it's an improvement. Further, we are going to optimize it one more step. There's one more optimization which is left, and I think that will give us the best possible solution. So guys, now we will be doing one more optimization to our previous approach of the semi-optimized solution. So in the semi-optimized solution, you can see that we are traversing the list twice, right? Somehow if we can reduce this traversal to once, we will be able to further optimize this solution to run in lesser amount of time. So let me create a new class called optimized, and let me again define the same solution method here also. So I'm going to paste this here, and now what I'm going to do is I'm going to write the steps. Now you can see that in the previous method, or in the first semi-optimized method, what we are doing is first we are traversing the list and we are populating this numdex of element in idx, and then we are checking that whether, like, then we are calculating this required element and checking if this required element is present in numstick and the index of both these are different. If that is the case, then we are returning that yes, the pair which adds up to form the target number is present, and therefore we return the result. But what we can do is we can combine these two loops into one. Let's see how we can do that. Okay, so the first step we will write is traverse the list, right? Now while traversing the list, we first calculate the current required, right, which is basically the difference between target and the current element, right? Now we have calculated. Now what we do is we check whether this current required is already present in our dictionary. which initially it will not be present. So what do we do is we add, since the current required is not present in our dictionary, we add the current element as key along with its index as value. So what effectively is happening here, in this case we are first adding, in the previous case we are first adding element by element and we are adding the index as the value. Now here what we are going to do is we are going to check whether the required value is present in the dictionary or not. In case it is present, then we have found our solution and we are going to return it. If it is not present, then we are going to perform this step of adding the element along with its index in the else part of the if condition. Let me write the code, you will understand better. So let me just copy again the parameter description. So I'll just copy this parameter description. Let me just copy it here. And that's it. So let's write the code and try it. So I'll create something called as a numsticks again, which will be dict. Then I'll just do a traversal for index comma element in enumerate nums. Now here itself we will calculate the current required, which will be target minus element. Now I'll check if element in numdex.keys. I'll first write a pass statement here and then I'll do an else. So what will happen in the first iteration itself, right? Like in the first element, we know that the numdex key is empty and it is not having anything. So obviously this should be not element, this should be current required. So if current required will obviously not be present in the first iteration, like in the first element. So what we'll do is, to this nums dictionary, we'll add this element with the IDX. And what we'll do here is we'll return numsticks dot get current required comma IDX. So what effectively we are doing is, if the current required is not present in the numsticks, then we are taking that element and we are just adding this element to the numsticks. So what will happen is, when it will go to the next element, the numsticks dictionary will already be populated with the previous element, right? So the subsequent element, we can again check this numsticks whether the current required is present as a previous element in this dictionary or not, right? So let's try to run this and see if this is running in Leet Code. So I'll just paste it here and I'll just run it, and yeah, it's accepted. So I'll just try to trigger it again from the complete set of solutions. So as you can see, like it beats 88% of the solutions. So it's the best solution which we have got, and we did it by using a hash map. So O of n space followed by one traversal, which is O of n, right? So this is the best case solution possible for this problem. So yeah guys, just to recap, we solved this problem in 3 different ways. The first way was the brute force approach, which was giving us a time complexity of O of n squared. There was no extra space required. The second way, what we did is we did a somewhat of an optimization using a hash map, in which we are traversing the list twice, and while traversing the list twice, we were able to get a solution in O of n time complexity and O of n space complexity. Then we came to the best solution, which gave us a time complexity of O of n and a space complexity of O of n. So this is the way you can solve this two-sum problem. So yeah, let's meet tomorrow for the next problem. Thank you guys.